Hello everyone and welcome. And today we'll be talking about electrical grounding or electrical earthing. And I'm going to explain why it is important, how it is done, and what purpose it actually serves. So let's get into it. So the first question is, what is electrical grounding? Electrical grounding, also called earthing, is a process of connecting electrical equipment or an electrical system directly to the earth using a conductor. But there's something many people misunderstand. Grounding is not there to make your appliances work. Your television, your fan, your refrigerator can actually operate without the earth wire. The earth wire exists mainly for safety. Its job is to protect people, buildings, and electrical equipment when something goes wrong. So think of grounding as an emergency escape route. When everything is working normally, nobody uses it. For example, like an exit, an emergency exit, right? When everything is working normally, nobody uses it. But when there's a fire or uh, there's an emergency, then it is used, right? So just use the example of an emergency exit, right? When everything is working well, there's no need for you to use that. But when an emergency arrives, that's when it becomes very, very important for you to use. So grounding works in the exact same way. We connect all our appliances are connected to earth. If everything is working properly, there's no need for it. But when we have like an earth leakage or a failure of insulation and all of that, that is when the earth conductor comes into play. Does electricity really go into the ground? This is one of the biggest misconceptions also. A lot of people think because you connect the earth wire to the ground, it means electricity just flows to the ground. But this is actually wrong. It does not go to the ground. During normal operation, current flows from the live conductor through the appliance and back through the neutral conductor. That is a normal flow of electricity to the appliance, from the appliance through the neutral wire back to the supply. That is how it works normally. But current actually goes to the ground only in case where we have a fault, right? Let's say electricity flows into the appliance and there is a broken insulation inside this appliance, and when that happens, probably electricity gets in contact with the body of the appliance. So in this case, that is when that leakage current that is supposed to normally flow to the body of this appliance due to the failure of the insulation, that breakage current, that leakage current now is what is going to flow directly to earth. So grounding is not a normal return path for electricity. Instead, it provides a safe path only when something goes wrong, right? So mainly grounding is for safety, protection, and stability, not about disappearing electricity into the ground. So grounding doesn't carry current during normal operation. It is there to protect when things go wrong. So, how is grounding done? Firstly, grounding is done by burying an earth electrode into the ground. So basically, we have different types. The most common is copper rod. We also have copper plates that are also buried on the ground, right? So basically, you bury it on the ground. After burying it in the ground, you measure the resistance using using an earth resistance tester. You test the resistance once you are sure that your resistance is in the range of the required resistance, which for domestic installations is always 10 ohms and below, and for industrial cases it should be like I think 5 ohms and below. So once you measure that, then you are going to have your earth conductor that is going to be connected to that. You connect that to the earth conductor and you take it into the building to your dB or whatever, your SMDB or MDB, and from there you can use it to connect all your power outlets to it. So basically that's how it is. Bury your earth conductor, earth rod, connect a cable from there to your MDB, and from there you supply everything in the house. So we also need to understand that there are different categories of soil, right? We have wet soil, dry soil, and rocky soil. Wet soil normally has low resistance, and this is the best conditions for the best soil for us to have in earthing. And we have the dry soil, which has high resistance, which is poor for conduction. I also have rocky soil. This has extremely high resistance and is very poor for conduction. And this is one of the reasons why electricians often install earth rod deep into the ground. It is always installed really deep into the ground. Okay, so like I said in the previous video, we have different types of soil, and this, depending on the type of soil, it affects the resistance of that earthing, right? So we talked about the wet soil, which is extremely good because it offers very low resistance to the flow of current. We have the dry soil, which has very high resistance to the flow of current, which is not really good. And we have the rocky one. So in so many cases and in so many instances, you are going to see that when electricians or technicians try to bury the earth rod, they are going to put some materials on the ground like charcoal, salt. Some people even put lemons and all of that. These things are used to help increase the conductivity of the soil around the earth rod. That's why you see we put salt, because salt dissolves in water and produces ions. These ions improve the conductivity of the soil around the earth rod. That is one of the reasons. Charcoal helps to retain moisture around the earth rod, which can improve the conductivity. And again, this solution we are bringing to solve the problem of resistance also comes with a limitation, right? Over time, salt can corrode metals around and conductors, reducing the lifespan of the grounding system. So you can see this earth rod is corroded, and that is one of the limitations of this. And in order to counter this situation, this is where we have bentonite. Many installations avoid using ordinary salt, and they use instead specially designed grounding compounds such as bentonite or conductive concrete. So this one absorbs water and swells, keeping the soil moist and reducing the resistance. And it provides and for conductive concrete, this one provides a stable, long-lasting, low-resistance part without excessive corrosion. So this is the explanation for that. So the goal is simple. We need to have low resistance, high safety, and long life for the electrical system. So basically, that is the main job of the earthing system. So a lot of people also confuse between neutral wire and earth wire. A lot of people think they are the same thing, but they are not the same thing. Although both are connected to the ground at one point in the electrical system, they have different jobs. The neutral wire is part of the normal electric circuit. It carries the return current. Live current goes into the lamp, it flows through the device and comes back through the neutral wire. So that is the normal procedure. And this is the earth connector connected to the ground at only one point. So neutral carries current during normal operation, completes the circuit connected to the ground at the source. That is all for neutral wire. Earth wire, on the other hand, is just a protective conductor. Under normal condition, it should carry little or no current. Under normal condition, it should carry little or no current. But in case of a fault, like let's say a leakage in this washing machine, let's say we have a failed installation, right? And we have current leaking to the outer body. That is when this earth conductor comes in. That leakage current now will flow through this earth resistance and earth conductor and go to the ground. So basically, that is the difference between the two. And for the conclusion, it is important to note that grounding is used mainly for protection. It protects people from electric shock. It protects equipment from damage. It provides a safe path for fault current to flow to the ground, and it allows fuse and circuit breakers to disconnect dangerous faults quickly. So basically, that is it. If you have a device that is connected without earthing, in case of a failed installation, someone touches it, the person get shocked. And with grounding, if you have proper grounding, if there's a failed circuit, current is going to flow to the ground, the leakage current is going to flow to the ground at the same time, leaving the circuit breaker to trip, so the fault can be fixed. So thank you very much for watching this video. If you find this video helpful, please like, subscribe, and share. Thank you very much.